Welcome everyone to episode 2 of our Kangaroo Flat Hybrid Home, here with David from Ecowise Homes.
Hi guys.
What are we going to get up to today, David?
Well guys, last time we checked in with the video, we were about to pour the slab. Since then there's been a lot happen. We've got our frame up, the roof's on, and now we're locked up and the brickies are here. We've just done our blower door and we've got good results, so let's go inside and check it out.
So this is our client's forever home. They've got a young family, they want it to be healthy, comfortable and energy efficient. And so that's been a huge part about how we can focus in on the clients as a family unit. So one of the biggest things you can do is try to remove the scale that a garage or cars bring to the form of a home. And we've done that deliberately here by facing the garage away from the street and the road and making it more part of the form of the overall building as opposed to just having it as the front and center feature piece like most homes are. So some of the really cool things that we've introduced here, we have on previous projects, we've provided an XPS insulation board here to provide a thermal break. So that there is the laundry or pantry door inside, the pantry door inside. And that's an airtight door, and we've also got our insulation to provide that thermal break, and that's usually the weakest part of where the slab and the outside air meet just under the bottom plate of a stud wall. We've got our typical boxes, which you may have seen, for those who are familiar, may have seen in some of our previous episodes. So this is our airtight barrier in this project, the external wrap here, and where we've got power points and switches, we've got those air-contained boxes. So they're nice and airtight, they're from Tight House, or Efficiency Matrix. As we move along, we look above, we've got a portion of the HRV, continuous mechanical ventilation ductwork, running outside of the fabric of the thermal and airtight layer. So we've been able to encapsulate that, run it over the top of the storage in the garage here, and then that goes upstairs and provides the ventilation requirements up there. One of the really cool parts of this building from a design perspective is where I'm standing, the entire upper floor, the entire upper form is floating above my head. There are no supports, it's completely cantilevered out. And this will be covered over once there is a garage door installed, but it's one of my favorite parts to see during the build. So it's really interesting to see the details required to achieve that external airtight or the external wrap airtightness. Above me, as I mentioned, the top story cantilevers out over the top. But what Dave and the team have done here is installed strips of the weather resistive barrier or the wrap first, so that when the trusses are abutted to the framing of the upper story, they've got the ability to continue that airtight layer and have that continuous WRB. So that comes underneath here. They've got the starter strip that when they've then installed the truss against, it's taped off, and then it continues up to the wall, to the wrap on the wall, and that's taped off as well. So it's nice and continuous. It's always mindful to keep the communication high on site for airtight buildings too. So David and the team from Ecowise have got that all covered here with their signage. And I think it's about time that we probably went around the back to showcase some of the other constraints that we've worked with on this design. So we're at the north side of the home now, and it's a great opportunity to talk about some of the constraints that existed, but also shaped the design response. So the walls are on angles here, and what I have in front of me is a overland drainage channel. So this is an easement. So we've built right to the edge of the easement, and hence why we've also put a second story on this particular project to try and maximize the really small footprint of the building. We've got a beautiful bushland setting to the north, but it also provides a heap of overshadowing when we're trying to optimize our solar gain into the home. So we've been able to put the drone up, work out the heights, put that into our computer program and model what the overshadowing impact is, and also adjust our window locations and sizings to suit to try and optimize the solar gain into the home. Another really important part of that, when we did the studies, was we determined that we needed to have a cathedral ceiling for the alfresco roof to try and allow as much sun into the living space as we can, but also provide an extension of this wall with this wing wall here so that we're stopping or reducing that road noise impact that we often get here when we're next to a main road. All right, David. I've talked a little bit about the wrap, but I'm going to get the master to do it. So can you walk through, maybe from starting from the ground up, exactly what we're looking at here for our wall, including the windows too, because we have done something a little bit different to the graded sill pan as well on this one, 100%. I believe.
So the building wrap you see here, that is going to be our airtight building wrap as well on this project. So to start at the bottom, we have our slab connections. Obviously the slab's airtight. In previous projects, which I'll show you inside, we used the air seal plate, which is the second bottom plate. On this job, we actually just used the normal standard bottom plate. As we did on our past project, our our building wrap gets polyurethane to our bottom plate, so it's all air sealed and continuous. Our building wrap is all detailed correctly, so it's 100% continuous. Any penetrations that we have, whether it's a plumbing pipe, split system unit, or electrical wire coming through, it all gets taped and sealed. We use Proclimer tape on this project. And then it goes all the way up to our plywood, which sits on top of our top plate, and then it gets continued through to our plasterboard. And we'll explain a bit to you once we get inside about how we made things airtight and that sort of thing. But to talk about the windows are the most vulnerable part of any sort of wall system and that sort of thing, from a thermal performance, but also from a longevity with bulk water and that sort of thing. So we always install some form of like a sill pan system. On past projects, that's been a PVC product that we actually purchased. On this job, we just used Proclimer seal tape. That's been installed with a weatherboard, so it's got fall out, and then we just have a bit of 2B1, which is a piece of timber, as a back dam, and that's been fully wrapped with this Proclimer seal tape, folded up the corners and that, so it's all continuous and sealed. One really important thing we always do when we're taping our windows, we always leave that bottom open, so if this window does leak and water does get in there, they can always drain out, and then you can see we've got our tape right around the side, up the top and down the other side, so any sort of condensation that does form in this cavity, it always can drain out, so it's not an issue.
Yeah, great. And what's happening over here on the wall, David? Like you've finished your external wall wrap, just short. It looks like at the top quarter of the truss.
Yep. So you can see this building wrap here up to the tape up the top there, that's all part of our airtight system. But the tape at the top there is just what I call wind washing wrap. So we're obviously going to have a cavity here, ventilated cavity on our wall system. The air can flow all the way up. And if we didn't have any tape up above the trusses there, that air would actually cross over into our insulation and have a wind washing effect and devalue the performance of it. So we always install it so it sort of goes up just below the bottom of the top quarter of the truss. That way air can fly up in our roof cavity and that thing. Yeah. And I just wanted to point out, I'll get you to chat about it, of the roof system that we use as far as a vented roof space and that sort of thing.
Yeah, so it's a ventilated roof space as opposed to a dedicated ventilated cavity. And the reason that we approach it this way is that we have the mindset, and there is no right or wrong way to this, it's what is going to effectively work. And we believe that by having a ventilated roof space and having an insulated blanket underneath the roof sheet, that it's actually preventing the problem by reducing or mitigating condensation forming on the roof sheet, as opposed to, I suppose, when we do have our ventilated cavities on our projects, where we do find we have a lot of condensate occurring under the roof sheet, and it's constantly having to then drain that condensate or moisture out of that space. So we kind of trying to prevent it as opposed to then letting it occur and then dealing with it in this instance. There's also a really interesting feature in this home, which we'll talk about more in a second, but we do have a dog door. As much as we love our dear friends, furry friends, it can cost thousands and thousands of dollars for pet doors, but we have a really great solution here that's probably more a few $100s. Yeah. So I know we get a lot of questions about that. So we're inside now. It's a good opportunity to, I suppose, look on the other side of the wall, so to speak, David. Do you want to walk through from this perspective what's occurring with the...
So as I was saying earlier, that on that previous project, we installed 2 bottom plates. On this job, we just installed the one standard bottom plate that you would on any other home, with a slight change of when we actually butted the wall plates together. On the bottom plate, we just gave a little bit of silicone, and the same with any corner junctions now to get it all continuous. Obviously, the slab's airtight. We then just went around with a caulking gun and gave a bead of polyurethane right around the perimeter of the slab. So it's all continuous airtight. As I described outside, our building wrap is all continuous and all airtight. Any penetrations are sealed. You can't quite see it, but on top of our ribbon plate, which is the top of our double plates, there's a piece of ply that gets connected to our building wrap and then to the plasterboard with a bead of polyurethane. So it's all continuous, and any penetrations are all sealed.
And you can go back and look at some of our previous episodes to get a really good look at what that plywood connection looks like before the plaster goes on. let's talk about the framing methodology here as well, because again, this is, I guess, probably one of the more unique parts, further to the plywood connection to continue that airtight seal from the external wrap to the plaster ceiling. What's the approach here, Dave?
Yeah, so we're really unique the way we build. We actually build in 2 different framing stages, and that also requires our trades to do 2 different roughings. So we build all the external walls, any internal load-bearing walls. And the reason we do that is so we can get continuous plasterboard over the home, and that allows us to achieve really good airtight numbers. There's a few sort of products that we need to do to achieve that. Is one of them is the Simpson Strong Tie deflector screw. So you can see up here, the orange screw directly above me there, that gets penetrated into a truss or noggin as you would with a normal L bracket. But yeah, like it's a bit of a different method, but that's the way we achieve the good airtight systems and that. And while we're talking about framing details, and Anthony, like I know you described or have details on all your plans of different wall build-ups and that sort of thing, like what's the benefit of this sort of wall junction compared to a normal 3-stud corner?
Yeah, so we know just through previous research from various sources that by spacing our external studs at 600 centres and reducing as much timber as we possibly can, what that allows us to do is put more insulation in the wall. So we've got less thermal bridges, we've got more insulation, and we're actually getting a far better outcome, thermal performance outcome. And this is one of the methods, right? So we have where our internal walls meet our external wall, rather than having your stud on either side of that wall like you would typically see to fix plaster to. We've just got these simple noggins, and then that allows for the internal walls to be fitted off to it. It's a good opportunity to probably have a look at an external junction as well. You know, like we've mentioned this a few times, most commonly known as a Californian corner.
Come over.
So, what I really like what you've done on this project to previous ones though, David, is that you've got the leftover offcuts of the plywood that you used on top of the ribbon plate on the top plate for the airtight connection as the piece of timber to pick up the plasterboard when it gets installed. So you've actually got one less stud again. So this is really technically a 2-stud or 1-stud corner. You've got 1 stud in the corner there that picks up the for the external fixing locations, and then you've got 1 stud on this wall here, and then the plywood is able to pick up the plasterboard here. So that's fantastic.
So if you can imagine on a normal sort of construction build, there'd be a stud here, these noggins wouldn't be here. Insulators will come in, insulate this whole home. This little cavity behind here would get left with no insulation. The same with that corner there. There'd be another stud going back that way, and that corner would have no insulation whatsoever. I know you speak of it a bit, this sort of adds up to about a 5% loss of insulation.
So we recently had a great chat with Tony from TS Constructions on our podcast, and he'd also done his own research into this, and he calculated that if that all of your external wall junctions on your corners and where your internal junctions meet your external junctions, it ends up being about 5% of the thermal envelope. Now, Sustainability Victoria have determined in their research that can have up to a 50% reduction in the overall thermal efficiency or the thermal envelope's efficiency of your home.
That's pretty big numbers.
Big numbers. It's really important to make sure that those junctions are insulated.
While we're talking about plasterboard and sort of airtight being all continuous then, Anthony, we see here we've got the plasterboard in the ceiling there, we've got some triangles happening. Would you like to describe to everyone what's going on here?
This is, the triangles that you can see above us here are offcuts of the 140 studs. So again, another really efficient way of using the materials that are already on site. And it's dropped down 150 millimeters approximately, 150 to 170. And what that allows is to provide the flexi duct of our continuous mechanical ventilation with heat recovery to come inside the airtight and thermal layer. Now that's really important that we have that inside the thermal and airtight layer because they're not insulated ducts. And we don't want to run into any risk of any particulars getting stuck in those ducts or any moisture that may then lead to, any sort of nasties growing in there and then being distributed through the house. So we've got that, but we try to minimize it because we know that's extra materials, we know that's extra labor, it comes at an additional cost. So we try to be very selective about the locations in the home when designing it where the drop ceilings will occur. And the way we achieve that is by having bulkhead grills as opposed to a ceiling mounted grill. So that allows us to get that fresh air supply into the bedroom here, but not have to go through the extra labor and material and expense of dropping the whole ceiling in this bedroom as well.
I will just point out that the majority of times you will see the HRV ducting in the ceiling above that will be like an Intello membrane or something like that. We opt for plasterboard. I sort of feel with having this ceiling above us here in this bedroom, being the airtight plasterboard, also the seam plasterboard, it just makes it easier for us to continue it all the way through. There's less connection, less labour involved in that. That's why we opt for the plasterboard over a independent membrane.
Yeah, and you know, we'll showcase exactly how airtight plasterboard is in a moment. So there's been a slightly different approach to creating the air seal between the window reveal and the jam stud of the window here, Dave. Do you want to explain what you've done and how you've achieved it?
So as I was telling you before, the building wrap's all continuous, and you actually see on the sides of our window openings that we continue the building wrap all the way to the inside of the studs. It's all taped, all continuous. So then we've got our window reveal here. We actually have a product from Bowen's Hardware, which is from Schaefer & Co., which is their sort of expanding foam tape. It's their passive range, it's 40mm deep. But that's all continuous all the way down the sides of the window to get a really good air tightness with this home. We then again used some straightening screws in our reveals. It's important to point out that these windows are going to be square set with an easy reveal over the top. So, you know, we wouldn't be using this sort of system if we had architraves that were just getting painted, because I would not like my painters to fill those holes. It's a bit too big for them. So,
So for those who aren't familiar with this product, where can they find out more about it? Because I haven't seen this in too many builds to date.
Bowen's Hardware is the best shop, the best place to reach out to and have a chat to them about it. If you are looking to, you know, make the opening between your studs and your window reveals airtight. And
this is replacing the polyurethane sealant that we used previously on projects.
And
then it will just expand and become airtight.
We're always sort of exploring different options to make things a bit more cost effective, a bit more efficient on site and that sort of thing. So that's why it's always evolving.
And these windows are again from Ultimate.
That's right.
Which is they now have replaced the Zendale series with their Legend series. And then there's the tilt and turn windows that you've probably quite oftenly seen in our projects. It's
you know, a good window company, good product, good service, Ultimate Windows. So tilt and turns, your lift and slide door over here. So again, it was originally on its roller seal, lifted up to put on its roller casters.
And we really prefer these windows for a couple of reasons. They have a great air tightness. They seal well, as you just said, when you crank it, it seals. And also, you know, the uPVC from our own research really is the best value to performance ratio. It's a next level up from the performance values from those double glazed aluminium windows that sort of seem to cap out. So for the mechanical ventilation system here with heat recovery, we'll have the extractions where you would typically have any exhaust fan. So in your bathroom, near your shower, en suites, even in the laundry in this case, because we do have moisture occurrence in there. There's also one that's usually installed really close proximity to where the range hood is as well, 1.5 to 2 meters. But, you know, might be a great opportunity, David, just to walk through the home and to get a better perspective of what the system looks like without the plaster. So you can see we've got an extraction grill here directly above our shower, and that's, as Anthony sort of said, that we can't really use the wall grills in the bathrooms and that sort of thing because we need them directly above our showers and the typical locations you would have exhaust fans. But let's follow these ducts through and see where they go to. So we've got the double ceiling through here just to run ducting. Like technically this sort of room you don't really need the double ceiling, but we just do it for the purpose to run ducting. Passageways are always a great place to be able to reduce that ceiling so that we can push the wall grills into each room.
You can see in this is the kids sort of rumpus room in here. You know, there is a air supply grill there, but you know, technically you could have gone away with a bulkhead or something over there, but I think what you've designed here is really good, that you can got the continuous ceiling, supply grill there, the ducts work all the way across here.
And we do have a really large supportive structure, so steel structure that is picking up the cantilever of the upper story. So by just reducing that ceiling height in here, it cleared all of those issues of trying to navigate the ducts through steel structural members and framing members, which then continues into where the entrance space is and the stairway upstairs.
Let's keep wandering. So as you can see in here, this is the entrance of the home. We're starting to get more and more ducts coming here, and it's starting to get pretty congested, that sort of thing. So to get from this side of the house across to over there where the unit's going to be located, we had to create a little bulkhead sort of system through the garage that Anthony showed you just before.
Yeah.
And it is very tight there. We actually just, to make that insulated, we couldn't use bulk insulation. We had to use XPS foam, sorry, and just 2 layers of it, and that way, you know, it's not sort of, you know, any thermal issues and that sort of thing. But yeah, we managed to get it all through. As far as air tightness and that, we actually used a part of a structural beam on the other side of that wall was an airtight membrane or airtight system, and also some plywood there as airtight system.
Yeah, that's a great solution. Just, you know, you've got your timber structure there already.
Yep.
Why complicate things by putting additional membrane in there when it is airtight itself?
Yeah.
And, you know, one of the things that we can't see right behind us here is there's actually a service void directly above, which allows us to get our ducts upstairs as well.
That's
so
right.
there's a lot happening in this little congested space, but it all worked out, and we were able to resolve that in, you know, in the design and documentation stage.
Yep.
Not so much during the construction, when this would have been really complicated to try and work out.
Yeah, for sure. Let's get going.
Cool. So we've just walked through the kitchen, and now we're into what will be the pantry and the service area for the HRV unit itself. So a centralised system from Zender, Fantech, and we'll be supplying the units for Drew from Passive Tech will be the installation.
Correct.
They've done an excellent job as always. And so yeah, this is what I like to refer to as where all the spaghetti mess comes from, and it all will be plugged into the manifolds and then into the system itself.
Yep.
We've got 2 larger grey ones here. What's happening with, in this instance here?
Yep, so one of them's the supply grill, and the other one's the extract grill and that sort of thing. So it's a 2 different sort of system that gets combined with the HRV. A unique thing that we've done here on this project, in this walk-in pantry, we actually dropped the ceiling, this double ceiling, to give ourselves 190mm cavity. In the other rooms, I only just used 140mm cavity. And as you can see, the ducts sort of spiral across each other in a few different places and that sort of thing. It just gives the installers that little bit more room to get the ductwork through and that sort of thing. So yeah.
And if you're not working this out in the pre-construction stage, you are opening yourself up for a multitude of headaches during construction to try and work out how to run these ducts. This is something
definitely.
I've seen happen time and time again, and we've learned through experience ourselves.
Yeah.
So we've been doing a lot of blower door testing recently as builders are becoming more aware of the actual test itself and what the ramifications of an oversealed home can be. And what we've learned is that the numbers from the previous CSRIO document of around 15 air changes an hour being the average is that most new homes are much lower or much more airtight than that. In fact, they're all under 10 ACH, under 10 air changes an hour, and even some of the volume built homes are hitting around 5 air changes an hour, with some of the custom or franchises being below that again. Now, what does that mean? Well, it means that you may now need to introduce mechanical ventilation to provide a fresh air supply, because it doesn't have the ability now to naturally change. Under our National Construction Code, we are meant to be aiming for 10 air changes an hour, and there was also an addition into one of the drafts that stated that at 5 air changes an hour or less that you were meant to implement mechanical ventilation. So if you're a builder and you're watching this and you're curious, I really encourage you all to go out there and actually blower door test and get a baseline of what your builds are doing, because it's one thing to be leaky, but it's also another thing to actually be oversealed. And I personally think it's quite easy with some extra detail and attention to get a well-sealed home and a much more comfortable and energy efficient home as well.
So Anthony, on this project, we're doing something slightly different with the airtight sort of system. Would you like to explain to everyone what we're up to with this?
Yeah, so one of the really fortunate things that we've been able to do is have a sensor array in a previous project. So we've got sensors on the inside of the wrap here, and we've got sensors on the inside of the plaster, and we've got that on the different orientations of the home. So we've been able to monitor over a 12-month period where any condensation may occur, or any moisture issues or whatever it be, which there's been none, absolutely nothing, which is great. And we know that that system's working now. So what that's given us is the confidence to use the external wrap as our dedicated air barrier, and then not go through the expense or additional time of making the plasterboard like 100% completely airtight.
And that's just come about from a conversation that we were putting in a lot of labour to ensure that plasterboard is airtight. Like, it sounds relatively simple just to use the plasterboard's airtight system, but there is a fair portion of labour that's involved to ensure that it happens when you have penetrations as far as power points, plumbing, walls connecting to internal walls to make all that work and that sort of thing. So that's where it's all come down from. And you even run that through a software program, haven't you, to ensure we're not going to have any condensation forming?
Well, we have, yeah. You know, we've done a software analysis on the moisture transportation in that assembly as well. But, you know, more importantly, like our sensors are live, they're collecting live data and they're verifying it for us as well. You know, it just goes back to why we started out doing this methodology in the first place, and that's using standard materials, standard building practices, and always improving on that. And this is one of those items that we feel is an improvement, but still maintaining the high performance outcomes that we want to achieve.
G'day, how you doing? My name's Lee from Masson Rangers Masonry, and I'm with Dave from Ecowise and about to give you a bit of a rundown on a bit of brickwork around the job site.
Yeah, so Lee, I might ask you a few questions, mate. What's involved for you guys when you first come to a job site? Like, how do you determine your course height and that sort of thing?
Well, when we first come to a job site, we're basically governed by window heights. You want everything to work from the top of your window to the bottom of your rebate true. You want everything to be nice and even. You want window spacings to be nice and even between panels.
So you mean from here to the other window there, that way you can lay full bricks or half bricks and you don't have to worry about cuts and that
Correct,
sort of
mate. The less cuts, the better. Obviously, Dave, you go through the brick that the client wants to use. Obviously, we've gone with the off-white mortar and the white sand, which will give a very nice white look.
Beautiful.
And a good finish with the flush finish.
So for the guys watching on at home that don't know what mortar is, can you do, what components make mortar?
So it's basically a 1 to 6 sand mix. Sand being the 6, cement being the 1, and lime, and plasticizer weather dependent. During winter, sometimes you won't need to use it because it's nice and cool, and you get a lot of life out of the mortar. Summertime is a bit of a different story. You'd be sort of working against the weather.
So the lime component, what does that do to your mortar?
Just gives it good workability and basically helps with the curing process.
Yeah, very good. Excellent. And obviously you lay a very good brick yourself and that sort of thing. So how do you guys keep like it plumb and straight and that sort of thing? Like, I see you got some steel set up in the corners. Can you like describe to everyone what that is?
Yeah, mate. So basically what we have on the corner here is called a profile, which gives us our plumb both ways of the corner. And then we mark a gauge on the profile, which will give you an even 10mm bed joint to the windows that'll be spaced at obviously a multiple of 86 off the top of the floor. And yeah, just trying to be as neat and clean as possible.
And then you have this string line that you obviously put through to profile to profile.
Correct, mate. We've got a gauge on every string, a gauge on every course, which we lift up and down to suit the course of brickwork that we're laying at the time. And obviously we work from the bottom up. You have a flashing that goes down on your second course with a weep hole, which obviously allows for any moisture to exit the wall with the 40mm cavity. And yeah, a bit of airflow.
Very good, mate.
And they're fire weepers, which obviously you got a bit of bush behind you.
With bell rating.
Correct, mate, which will keep the embers out.
Very good, mate.
So yeah.
Well, you're laying a good brick, Lee. Keep it up.
Thanks, Dave.
Cheers. Thanks, guys. I hope you enjoyed that episode.
Yeah, we're really excited again to showcase another project that we've collaborated on. Look, there are things that are different from our previous ones as well, so if you have any questions, always reach out to say hi. But the next episode is probably going to be even more exciting because there is a very unique thing about this home, and it is going to be completely automated. This home will be able to give us that information that tells it how to be more energy efficient and how to improve into the future.